Hello and welcome to the Unit 9 podcast on section 19.2. Today we're going to be talking about strong and weak acids and bases. I'm Mr. Sakaguchi.
I'm Mr. Lin.
Here we go. The strength of acids. So strong acids, we find that there's a correlation between their ability to dissociate and their strength. So strong acids dissociate completely and as a result have high conductivities, whereas weaker acids, they don't dissociate as well and have lower conductivities.
An easy way to test for strength of an acid or base is to just stick it through a simple conductivity test as shown in the figure on the right, because when acids and bases dissociate, they form ions, and ions are conductive.
Yeah, that makes sense if you think about it. If I have a bunch of ions in the strong acid solution, the light should shine brightly, whereas if I don't have as many in a weaker acid, it should be not as bright. With respect to the Bronson-Lowry model, here I've taken our strong acid, our water, and have our conjugates labeled. So Bronson-Lowry acid, Bronson-Lowry base, conjugate acid, conjugate base. So strong Bronson-Lowry acids have weak conjugate bases, and these are weaker than the Bronson-Lowry base.
Now this results from that stronger attraction that the water molecule will have for the hydrogen ion than the conjugate base will, and as a result, you will have the hydronium ion in larger concentrations in your solution. So this will push the reaction forward towards your product side.
Yeah, so it can only go forward because the X minus doesn't have any attraction for this as much as this one does.
Right.
For weaker acids, this is more of a system where, again, acid base, conjugate base. I put the double arrow here because this reaction tends to go backwards as well as forwards. Weak Bronson-Lowry acids have strong conjugate bases, and these are stronger bases than the Bronson-Lowry base.
And as a result, you don't have as great of a high concentration of your ions floating around. Your conjugate base is going to have a greater attraction for your hydrogen ion than the strong acid, and as a result, you're not going to have as strong of an acid.
We can also look at our weaker acids, and because they're weak, they're going to form an equilibrium between the unionized versus the ionized form. So we can have these double arrows as I showed earlier, and because we have these double arrows, we can generate KEQ expressions for them, just like we did during our equilibrium unit. But instead of calling them KEQs, we call these KAs because these are specific for acids, and the higher Ka means the stronger the acid.
And the setup is the same, but in slight difference that you might notice is that our product now is going to include the proton ion and then the conjugate base ion floating around.
And water will not be included in the expression.
Right.
Same thing with bases. Strong bases will dissociate completely. Weak bases only partially dissociate. Again, for these weaker bases, we can come up with KB expressions, which are like KEQ expressions specific for bases. And again, we do our products. So for our reactants, again, the water doesn't count.
Right. But you will notice that the hydroxide ion is now produced. So in this example, in this classic setup, we have an Arrhenius base is being used.
And the smaller the value of KB, the weaker the base it is.
Right.
So what's the difference between strong or weak or concentrate and dilute? Sometimes these all kind of get thrown together and get confused. When I say dilute or concentrated, this is referring to the number of acid or base molecules. So it refers to how much is actually dissolved.
Right. Versus a weak or a strong base actually has to do with how easily the solution will release or produce hydrogen ions or hydroxide ions into the solution.
Right. So in other words, it's possible to have a dilute solution of a strong acid or a concentrated solution of weak acid.
And even with a comparison between the two, they could both equally affect a reaction in the same amount, depending upon their concentrations and the weaknesses.
That's right. I think that's it.
Yep.